Well, hi, good morning. Thanks so much for coming and keeping me company here while I work on this radio. It's June 25th. It's another fantastic weather day. So again, I don't want to spend too much time in here. Yesterday I did a couple of capacitors that were difficult to access. When I tested them in my capacitor tester, they tested not so bad. Maybe not perfect, but not so bad. And now I'm facing a bunch more similar capacitors and wondering about the value of the effort and the work and whatnot. In particular, these larger ones here, as you can see buried down in here. There's 6 of them all together in this radio here. Difficult to access, not as tough as yesterday, but they look fantastic. The end seals look good. Everything looks good on them. The capacitors I've taken out of this radio, they have all tested. Not terrible. And I think I'm going to focus on a couple of easy ones here. Smaller ones, which do not look to be in as good a shape. That's one here. And its brother over here on the other output transformer. These ones have got a pink paper cover. None of the other capacitors have this pinkish color, and I'm just wondering, is that to indicate something special about these capacitors? And what could be special about them? The only thing I can think of is these are temperature sensitive capacitors. Well, I'd say fat chance on that. They don't look like temperature sensitive capacitors. They look like ordinary ones, and their location out here on the output transformer doesn't make sense to put a temperature sensitive capacitor. The purpose of a temperature sensitive capacitor is to compensate for drift during the heat up phase of the radio. Something like that's going on. So they are normally located up in the front end of the radio, up, near the antenna and the tuning area, and that maybe in this area they would not be on the output transformers. So I'm going to change these two. Just convince myself of that. And we're going to flip this over and look at a pile underneath. There's another one buried. There's 2 more over here actually. They're connected to this input. Which input is this? This is the phono input, I think. Let's just check. Phono input. Phono input balance control is the other one. Well, maybe those two got to go too, because the phono, of course, is a very sensitive thing in terms of signal strength. So these capacitors are, and they would appear to be conveying the signal from here. If they're in trouble, the signal's going to get weakened and maybe get out of balance. It also could cause a tonal effect too. I'm just making this stuff up, trying to justify what I want to do and what I don't want to do. That's how we go through life, by the way, justifying decisions already made. And what is this doing out here? Okay, I have a part which has fallen out of something laying on my bench. Boy, does it look like something that came out of the, hate to say this, came out of the record player. Oh my gosh. Okay, not sure about that at all. Don't think it belongs in here. Oh, that's disturbing. Okay, now I'm all disturbed. I also have these 2 capacitors that I cut free yesterday, and I might as well replace those properly too. Okay, that's the work. Now I'm going to go for a coffee and wonder, what the heck is this part I just found? My God, what am I going to do? Where'd that come from? Oh boy. Trouble. Well, there is something special about these pink colored capacitors, I believe. Let's take a closer look with the other camera there. What is special? 250 volt. Alternating current B. .400 volt alternating current B. Now, can you read the next number? 1000 volts. Let's look at the other one here. 250, 400, 1000 volts. That's what's special about these capacitors. So, wow, okay, 1000 volts, and what's the size? I got the size just hidden away. 1000 picofarad. Okay, so I see those on the schematic. Let's have a little look and think a little more about this. So my capacitor stock is pretty much full of 600 volt capacitors and lower. I don't have any that have a 1000 volt rating on it. Here's the capacitor right here, 1000 picofarad. It's a 0.001 microfarad capacitor. You see its location here. It's between the plate, or between the terminal and the output transformer and another terminal. This is a very common place for a capacitor to be put. Exactly what this is doing, I have to get the book out and read it again, but we can guess. It's quelling any RF that might have made it this far, just shorting it out basically. Why 1000 volts though? Why 1000 volts here? This kind of gets me a little bit. I have to get my book out again and see if I can find a reference to why you put such a high voltage capacitor here, but I see it done commonly in radios. So obviously there's something that goes on here that can generate a very high voltage, maybe during startup or some, I don't know why 1000. I'm going to stop and look into this a little further and see if I can find a reference to why you put such a high voltage capacitor here, because frankly I don't have one. So either we leave those in place, or I put in a 600 volt capacitor and assume that's going to be fine anyway. And this is a 1000 volt capacitor when it's new. Could it really take 1000 volts now? I don't know. I got no way of testing that. Yeah, I'm going to look into this a little further before I just jump in and change those two out. Well, my research has been fruitful. I'm using my key book, Elements of Radio Servicing. This is from, I think, the late 40s, I think. I'm not sure. In this book, it refers to that capacitor 3 times. I'm going to read one of the references 3 times. One time it refers to it as being a capacitor that prevents oscillations in the output. Now this had to do with a push-pull amplifier. Is it specific? Is that application specific to push-pull amplifier oscillation? I don't know. But it did mention this stops oscillation. In another reference, it says the job of this is to catch and kill harmonics, harmonic distortions, or harmonic frequencies would be a better way of putting it, that are coming out of this tube. The idea is the harmonics are outside of your hearing range anyway, so this is designed to filter out those very high frequencies and keep them from reaching the output transformer. Just I guess, a waste going there. I don't really know what the problem is. The speaker's obviously not going to reproduce, 40,000 hertz, but so those are the two purposes. And he also said this often has an impact on the tone quality coming out of the speaker. So if you make this bigger and bigger, you can start draining the treble away from the output. So let's read what it actually says here. I hope you don't mind this. I'm just going to read this paragraph right here. Troubles common to the AF bypass condenser. So that's what they call it. Audio frequency bypass condenser. Condenser, I'll read it here. Condenser C12, the high AF bypass, often comes up as the cause of a dead radio. Its position in the receiver is not only at high DC potential, but also where the AC signal potential, the audio variation, is at its highest. This high voltage causes frequent breakdown of the insulation, resulting in a shorted condenser, which shorts out the audio signal from the primary of T6 and also the power supply at this point. The condition is quickly found in a voltage check. Plate voltage equals 0, screen or B plus voltage is low, since the power supply voltage drops with the heavy load. Condenser C12 may also be open. However, a receiver will rarely come in for this defect alone, since an open C12 will merely increase the high frequency response. And the customer may overlook this. In some radios, an open C12 may cause a high frequency oscillation. If this is the case, bridging C12 with a similar condenser or with a higher capacity condenser is the standard check procedure. When condenser C12 is replaced, a good quality of condenser should be used. Regardless of the original value, the voltage rating of the replacement condenser should be at least 600 volts. The outside foil lead or ground lead should be connected to the chassis. Condenser C12 sometimes is connected from plate to B+. In that case, the outside foil is connected to the B+. The replacement condenser should have the same capacity as the original. If the capacity of the replacement condenser is changed for any reason, it should be borne in mind that a higher capacity will cut more highs out of the signal delivered to the speaker, while a lower capacity will increase the high frequency response. That's the story of that capacitor, which I see in almost every radio I work on. That's what this guy's doing. So I'm guessing the high voltage rating is because, I'm guessing this a little bit, you have the B plus voltage of maybe 250 volts or something like that sitting there. And then you have the signal voltage, which is riding on top of it. This is the part I'm not so sure of, that it rides on top. I'm not sure about that. But if it did, then you'd have a large signal voltage on top. So you go from maybe 253 to maybe 400 volts here. I don't really know exactly what's going on. That's the reasoning for it. The book says at least 600 volts. That sounds good to me. And that's what I'm going to do. I'm going to replace these two, because obviously they're a little critical in the sound quality. If they're, well, what would happen to these? These would have, as they wear out, they leak. That's leaking B plus, right? Basically shorting out the output transformer, come to think of it. A little leak there. Yeah, I'm not sure what a little bit of a leak would do. In the book they mention open and shorted. They don't mention leaking. And now I see a piece of wire. What is going on here? Never mind everything I just said. Look at this. Just from staring at this, I've seen something. What am I seeing? So I'm looking at that blue wire, and I'm looking at what's hanging on it. What the heck is that doing there? Was that just hanging there? Or is it stuck there? Oh, it's just hanging there. Oh. Don't lose it. Oh, good, I didn't lose it. Steel wire, it's magnetic. What was that doing there? That could have been a headache in the making, because that could fall into the radio and then go somewhere you don't want it to go, and then good luck spotting that thing. Oh, lucky. It's my lucky day. Okay, so I'm going to go ahead and replace these guys. They were, what was the size? The size was something. The size was 1,000 picofarad, wasn't it? That's a .001. Okay, I'm going to change those two. Then we're going to play the radio. Then I'm going to go outside and revel in the wonderful weather. Okay, got a cat behind me watching my every move. It's my black cat Shadow. She wants to go back outside. She's going to keep an eye on me now. I'm her only way out. Just solder these in, and we're going to test those two capacitors that I took out. Okay, audio frequency bypass capacitors have been changed. Audio frequency bypass. Here's the two dead soldiers. Let's just see if they really are bad or not. At least in accordance with this style of testing, which is applying a high voltage and detecting the current flow through the capacitor, which, in an ideal capacitor is 0. And brand new capacitors, and I've demonstrated this quite a few times, put a brand new capacitor on here, you can crank this up to 450 volts and that eye pops wide open. Okay, 50 volts, what do you say? Right open. 150. 250. This is a 1000 volt capacitor. 350. Look at that. So this capacitor is in excellent shape. It's good enough shape, we will measure its capacitance here. Let me just give it a minute to... Actually, I'll take it off and let it discharge. We'll test the other one. Can't. I have to let these capacitors discharge. When this knob is free like that, it's a spring-loaded knob, it puts a short on the capacitor, so it starts discharging it. Okay, other one. Here we go. Right open. 150 volts. 250. 350. I can't do the 350. So, not terrible. Not perfect. Now I'm going to go back to the other one, which should be discharged. Not that it's going to discharge quickly on its own. It needs a short. The basic rule of thumb there is you discharge it with a short as the same length of time you charged it up. None of this discharge it, pow, suddenly. That doesn't really work all that well. Okay, measuring the capacitance. This is supposed to be a 0.001. What scale are we on for that? So here is 0.001 to 0.5. This might be a better scale. 0.001 to 0.005. Let's try this scale. Now the idea is I dial this until the eye pops open. There it is. Popping open. Anywhere else? Nowhere else. Okay, it's all working good. We get on the maximum eye open, and now we read it. How can we read it? The dial's in the way. It's 0.00. Which scale are we on here? We're on the 0.05 to pile of zeros, ones. So we're on this scale, 0.002, 0.0003, 0.001. That's where it should be. It's measuring 5 times as much capacitance. Does that mean it has 5 times as much capacitance? We're gonna take, this is interesting. I'm going to take another measurement. This is the other capacitor now. Very same spot, exactly the same spot. You gotta wonder about the accuracy of this. Well, we don't have to wonder long because we have another device here. Just going to move the camera over this way. Which is, my experience is, it's very reliable, unless the capacitor is leaky, and then this isn't reliable. I suppose nothing is reliable at that point. How do you measure a capacitance with a resistor paralleled across it? Well, maybe you can do some calculations if you know the value of the resistor. Okay, what do you say? You say. So that's basically 9,000. That's a 0.009 microfarad. Way high. Am I reading that right? 9,000 picofarad would be 9 nanofarad would be 0.009. It's supposed to be 0.001, isn't it? I got this all mixed up. Wait a minute, I grabbed the wrong capacitors. I have grabbed the wrong capacitors. Hey, it's these two. Okay, well that was interesting. Let's go back. Go back here. Oh, I got 2 more capacitors to change in there. I almost forgot about them. They're disconnected too. Good thing I didn't test the radio. Okay, let's try these guys. These are the correct ones. That first round was just a practice session. Okay, now we're doing the real thing. How good are you? Oh, that thing just popped open like a bullet. Now, that sometimes indicates that the capacitor is actually open circuited. There is no capacitance here. Let's see what happens. 150. Watch carefully. Now it's now closed briefly and then opened. So it indicates it is charging. We can go 250. Right open. 350. Hey, this shoot the works. 450. Stand back, everybody. Not quite open at 450. Capacitor appears to be in excellent shape. So better than the last ones. Okay, I'm just giving it a moment to discharge. Okay, here we go. My thoughts disappeared into a pile of political stuff that's going on right now in the country south of here. Here we go. What do you say? 50. It didn't even close. Yeah. It's working exactly the same as the last one. At 450, it didn't quite open all the way. This one did. This is a like new capacitor. Okay, give it a moment. 450 volts on there, you better give it a moment. Okay. Of course, the amount of charge in a small capacitor like this, I don't think is going to kill you. Going to make it jump, though. Okay, attempt now to read the capacitance. And this is supposed to be a 1000 picofarad, 0.001. Well, so that other capacitors I was reading here were, anyway, like that, 68. So 6800 picofarad, actually reading correctly. More good capacitors coming out. Maybe I should change my opinion of the. So 0.001 we noticed is here. Change my opinion. Oh, nothing. Oh, way over here. I got this on the wrong scale. There it goes, right there. And it's just a little above the 0.001. The accuracy of this, again, has to be questioned. Okay, good to do this on multiple instruments. I'd mentioned that if I ever went to the doctor and he took a blood test and the blood test showed something, I'd ask him to repeat the blood test before making any decisions around relying on. Okay, here we go. Same spot. Exactly the same capacitance reading on here. Now we'll go to my trusted meter. I have a number of meters that can read capacitance. This one I like the best. This is a great little device here. It scares the rest of the instruments in my shop when I bring it out. They don't like to see it. Here we go. You know, the old guys in my shop, they don't like to see these upstarts. So that says 1500 picofarad. So it's reading high also, quite a bit high. V loss, 0. So why would a capacitor read high like that if there's nothing wrong with it? Okay, right on the next one. And the answer is very same, 1500. V loss 0. 1500. But it certainly says 1000 on it. Where'd the extra 500 come from? Maybe the manufacturer just threw that in for fun. Have a little extra capacity there. Okay. That is over. I have to replace these last two. I should cut them out and test them right now. I'm going to replace them and then we'll, because I'm going to take a little break. I'll replace them and then we'll give them a test. Good. There she is, patiently waiting for me to let her outside again. Shadow, do you want to go outside? And there's her answer. Okay, 2 more capacitors to test. This is a 3300 500 volt rated transformer. The capacitor, these actually have 2 ratings on them. They have a 500 volt DC and a 220 volt AC. That tells you something. Maybe those 1000 volt capacitors, they're a 1000 volt DC rating, and that enables them to have a very high AC rating, since they're taking, as according to the book, they're taking quite an AC punch. Okay, so 50 volts. What does the capacitor say? Can you see the eye there? It's very hard to see in the camera, but right open. 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 350. And opening. So they are perfectly good. I hate to say that, but, well, I don't know. Perfectly good. Give it a moment. Gee, I wonder if the test I was doing was thrown off because there was still some charge left in this. Could that be the case? I don't think so, but I don't know so. I'll stick a voltmeter on it in a minute. See what happens. There we go. 50 volts. She's a winner. Something not right here. The eye is jumping around. Let's try that again. That's better. What's happening with this one? Now you probably can't see this, but the eye is flashing. As if there's something wrong here. Shadow, I gave you a chance to go out. She's ringing her bell. I gave you a chance to go out, and you didn't go. You just stood there and looked at me. Yeah, there's something going on here. Is this shaky? Still shaky. That's not normal. Shaky. What's happened? You know what it is? It's this. It's this. That. I don't know what it is. Nothing to do with the capacitor though. Okay, so we've tested these 2 capacitors. Now I've charged this one up. Yes, I know you want to go out, but you don't seem to know that yourself. What a demanding little cat. Hey, 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 don't get distracted. Distracted. What, you see a mouse? What do you want? Pay attention. Hello, hello. Calling Shadow. Calling Shadow. Hey. She's not like my other cat. My other cat is quite responsive to words and stuff. Okay. Yeah. Maybe I'm going to go let this cat out. Next thing we'll do, fire this guy up and make sure it still works after all the changes I made. Good idea, Shadow? Yeah, I know. Go out. Okay, time to test this guy. Volume down. Speakers are connected. No particular antenna other than the AM antenna. So let's see what happens here. Nothing's going to happen until I find the power cord. Where? Oh. Where is it? Whoops. Okay, now we're ready to go. Again, volume down. We're going to start this on AM. There's no power yet. We're going to turn the power on and keep an eye on the dim bulbs because I made lots of changes. Here we go. Okay, the lights are behaving normally. Volume slow down, magic eyes coming on, full power here. Volume up. Boy, it's so slow. Ooh. Sounds a little shrill. Well, hard to judge anything from a bunch of noises. Let's see if we can find a station here. It does sound very shrill, doesn't it? Now maybe it was muffled before and I didn't realize it. So we want to pick up a station here. We want to pick it up right around here, actually, way down here. Certainly has a lot more trouble than it did. Come on now. Come on, radio. Okay, we turn the antenna. I'm aiming for 590 here. There it is. Terrible to try this. Let's stick this on FM, and I got to come up with some kind of FM antenna. It does sound different to me. Hey, wait a minute. Am I hearing both channels? Whoops, that's not right. There's no balance control on this, except there's a thing to plug in the back that says balance control. There's no balance control. There really isn't. Okay, let me check with my head. You know what? It's coming out of both speakers fairly equally. So once I get my head up in the middle here. Okay, FM. Well, what can we get just with nothing? You never know. We get nothing. Nothing with nothing. Okay, I'm gonna fudge in an antenna here. Let's try this here. Okay, and the FM antenna goes down here. I'm not tuning FM. It's on this dial. Here we are.
States that are already conflating IUDs with abortion and are saying that they will also ban IUDs in their states. And so the idea that privacy would change our perceptions.
The whole world's freaked out over what's happening in the United States. Okay, I'm going to try to put on a little more FM antenna here. If I can. Nope, didn't do anything. Let me see if I can get a better antenna on this.
Rainy day strawberry, rainy day black cherry, or blue goo, just for something new. Make the...
Where'd it go? Well, not getting the greatest receptions here. That's not bad. Be careful about a copyright hit. Now, all these tone buttons are up and out of the picture. Let's fool around a little bit here. Bass up, treble down, bass, solo voice, weird how these are working. Soft. I'm gonna get a copyright hit for that, I bet. Doesn't stick, that's right. Pretty good volume. This antenna's not doing the miracle job I hoped it would do. But anyway, okay, situation is radio's working, both channels working, balance seems fairly good. It seems to have increased its treble quite a bit to me anyway, and that's fine because you can always roll it back with controls on the front panel. And better to have it there than to never have it there and you can't get it no matter how high you turn the treble. So I think it's a great improvement, those few capacitors I did. I think. And I'm going to leave it at that. That's a good thought. So I'm going to go out and enjoy the day. You should too, if you haven't already. And I'll see you tomorrow. I'm gonna think about this. I'm not rushing in to do a pile of more capacitors now. I gotta think about it. See ya.